Well, dear students, now I am going to solve some questions which are asked in competitive exam like NEET, JEE, AIEEE, etc. First question is there. You can note it. A beam of light from a source L is incident normally on plane mirror. Here is a source of light and it is a plane mirror. This ray is falling normally. They say when mirror is turned through small angle theta, then on a screen just placed above the source, the reflected ray get displaced by distance y. So how much is this angle theta? How much is this angle theta? Here is the source of light, it is the plane mirror. Then mirror is turned through angle theta like this. If this distance be x and the reflected ray turned by a distance y away from source, initially though it was normally going back on the same path, so what is theta? Here I have shown in figure. You know, there is one thing that when a ray falling on a mirror is reflected back, if the mirror is turned through theta, the reflected ray turns through 2 theta. So this angle is 2 theta, incident ray and the ray after reflection from M dash mirror. M is the initial position of mirror. M dash is the after turning through theta. Theta is small angle. And when theta is small, I have told you that theta equal to sin theta equal to tan theta equal to r upon radius. If this is y and this is x, then 2 theta equal to y upon x, or theta equal to y upon 2x. Simple. Here fundamental thing is that, remember it, when mirror is turned through theta, the reflected ray turns through 2 theta. This type of fact is not told. Okay, now second question there. Question number 2 is there. A ray of light traveling along the direction half I cap plus root 3 j cap. A ray of light incident traveling in this direction of propagation is this, and it represents any vector, is reflected from mirror, and the reflected ray travels in the direction half I cap minus root 3 j cap. So what is the angle of incidence here? What is the angle of incidence? Let this direction given by vector A. So let vector A equal to Actually it is half I cap plus root 3 by 2 j cap, and the reflected ray travel along vector b equal to half I cap minus root 3 upon 2 j cap. So these are two vectors. You may think here that if it is plane mirror here and it is normal here, so this is the path followed by vector A. It is reflected B. If this angle I, this is also I. So actually the angle between vector A and B is this. Then how to find this angle? From scalar product we know A dot B equal to modulus A modulus B cos theta. So cos theta is equal to vector A dot B upon modulus A modulus B. Here A dot B, I dot I1 होता है, I dot J 0, I dot J 0, J dot J1. So it is equal to this into this 1 by 4 minus होगा ये 3 by 4 upon modulus modulus A 1 by 2 square under root 1 by 2 square 1 by 4 plus 3 by 4 and into under root 1 by 4 plus 3 by 4 again. It comes out to be minus 2 by 4 divided by, it is 1. So cos theta comes out to be here minus 1 by 2. So theta comes out to be 120 degree. Means this angle is 120 degree. Then how much? This is 180 degree. So 2I is equal to. Actually I equal to I because we know from law of reflection angle of incidence equal to angle of reflection. I equal to R. So 2I is equal to 180 minus 60, 180 minus 120, 60 degree. So I is equal to 30 degree. So here angle of incidence is 30 degree. This is another good question here. Now there is a question on parallax. तो व्हाट इज पैरेलैक्स, ये डेफिनेशन बड़ी कहीं भी किताबों में डिफाइन नहीं लिखी. क्वेश्चन तो ये है, इन एन एक्सपेरिमेंट टू डिटरमाइन द फोकल लेंथ एफ ऑफ कॉनकेव मिरर बाय यूवी मेथड, ए स्टूडेंट प्लेसेस ऑब्जेक्ट पिन ए ऑन प्रिंसिपल एक्सिस at distance x from the pole P. The student looks at the pin and its inverted image from a distance keeping his or her eye in the line PA. When student shifts his or her eye towards left, the image will appear to move the right. Where is the object? मतलब x लेस देन f होगा, x बिटवीन f एंड 2f होगा कि x बराबर 2f होगा और x ग्रेटर देन 2f. I explain the question by diagram. It is concave mirror here. Here it is pole. Here it is object, then he or she see the image, keeping her eye in the line PA. It is object position. Now, if the observer turns his eye towards left, then image appear to right. I am repeating the question. In an experiment to determine the focal length f of concave mirror by UV method, a student places the object pin A on principal axis at distance x from this distance is x. From the pole P, the student looks at the pin and its inverted image from a distance, keeping his or her eye in the line PA. When student shifts his or her eye towards left, the image appears to move right. Here, for your knowledge, I am going to define what is parallax. You might have heard the term parallax in your lab, that remove parallax, but nobody knows what is parallax. When moving observer see two objects at different distance in the same line, in the same direction. Suppose here these are two objects. This is A and B, and observer going this way. Observer going this way, look at the two objects A and B. This is the observer, here moving observer. Then these two objects for the observer appear to move with respect to each other. This relative motion between the two objects in the same direction, when viewed by the moving observer, is called parallax. You might have seen when you travel along any road, the trees or the things closer to you move backward while the distant object move forward. ये बहुत कॉमन ऑब्जर्वेशन है, हम देखते नहीं. When we travel along a road, state road, then generally there are trees. The trees close to you go backward while the trees away from you move forward. This relative speed, relative motion between two objects is called parallax. If we anyhow see that two objects moving same direction, it means they are at same distance. Actually, it is because of relative angular motion. Suppose the observer goes from that point to this. This is the angle traveled, and here it is the small angle. So the angular velocity of the observer with respect to farther object is smaller than closer. That's why this motion appears. Is that clear? So when you move like this, suppose, so this object goes backward and this goes forward. So here in this experiment, I, when turned from right to left, the eye become moving observer. And he says if we turn to left, suppose this is left, my left, so pin here, image appears to move south. It is only possible If the image is closer, if image is here, then it will be opposite to that. Because it will move backward, it will move forward. तो अगर ये image between pole and P and A होगा, if this image is between P and A, then it will move along with I towards the left. So it is possible if image is closer to I, and it is only possible if object placed between F and 2F, F and 2F, then image will be beyond 2F and closer to I. So here it will be X जो है less than 2F और F less than X. तो ये इसका parallax. Please try to understand parallax. Actually in lab, when we see image, we turn we close one eye and turn our other eye, and keeping, when they appear to move together, then they are at same distance. Otherwise, if it is like this, so there is relative motion. Actually, our eye there, when we rotate our eye become moving observer. So parallax is the relative motion between two objects in the same direction of moving observer. Okay. Now 16 seconds हो गया. There are some more good questions. Let me solve for you. One more question I am solving for you. Then I will proceed to refraction. Here, a car is fitted with convex side view mirror of focal length 20 centimeter. A second car 2.8 meter behind the first car is overtaking the first car at relative speed of 15 meter per second. The speed of the image of second car as seen in the mirror by the first car. Here is one car, there is mirror in this is here, second car. Now this car is at rest, it is moving with the speed of 15 meter per second. The observer here, observe this in this convex mirror. Convex mirror is used to see the rear view of focal length 20 centimeter. So this image of this car in car 1, when this car moves, the image in this car will also move. So what is the speed of image of car 2 in car 1? You know, for spherical mirror, so it is distance 2.8 meter. Instantaneous speed 50 meter per second. 1 upon V plus 1 upon U equal to 1 upon F. This is your equation. V the position of image, not velocity. It is the position object. If we differentiate with respect to time, dx upon dt is the क्या होता है भाई? Velocity. So if we differentiate, actually d upon dx of p upon q is equal to q into d upon dx of p, or minus p into d q over dx upon, it is q square. In this formula here, p is 1, which is a constant quantity. So the first term 0 minus d upon dt, it will be minus 1 upon v square dv over dt, minus 1 upon u square du over dt is equal to 0 because focal length constant. Only image position and object position are changing. dv over dt represent velocity of image. d over dt represent velocity of object. From here 1 upon v square into dv over dt is equal to 1 upon u square du over dt, or dv over dt is equal to minus v square upon u square du over dt. This is one equation. Now from mirror equation again 1 upon v plus 1 upon u equal to 1 upon f. So u upon v plus 1 is equal to u upon f. है भाई, मल्टीप्लाई बाई यू, इस इक्वेशन को u से मल्टीप्लाई किया, और u अपॉन v इक्वल टू u अपॉन f माइनस 1 इक्वल टू f u माइनस f. It is u upon v. So v upon u is equal to f upon u minus f. Putting this value here in equation 1, sorry. So we get dv over dt minus f upon u minus f whole square into du over dt. तो फोकल लेंथ था 20 सेंटीमीटर, व्यू था सेंटीमीटर, 2.8 मीटर मीन्स 280 सेंटीमीटर. Putting all the and du over dt, you are again 15. So du over dt minus f upon what is f? 20. 20 u is minus 280. U is minus 280 negative होता है u, और minus 20 whole square into a 15. So how it will come? Minus 20 upon minus 300. Minus 300. Is it clear? Square into 15. So it is 1 by 20 minus 1 upon 15 square into 15. So it comes out minus square plus, it is 1 upon 15 minus. Minus means the image will be shifting in the direction opposite to incidence rays. So this is the speed of image in convex mirror of car standing or observer. I hope you will enjoy these questions. Thank you.